The question is, let P of Z be equal to Z to the power of 4 minus Z to the power of 3 plus Z squared plus 2A, where A is real. Given that 1 plus I is a 0 of PZ, A, find a real quadratic factor of PZ, B, find the value of A, and C, express P of Z as a product of real quadratic factors and hence find all the other zeros of PZ. Okay, well, what do we know about the polynomial PZ? Well, the coefficients are 1, minus 1, 1, and 2A, and they're all real. So since all the coefficients are real, that means that the zeros are either real or come in complex conjugate pairs. Zeros are real or are pairs of complex conjugates. Okay, well that means that since 1 plus I is a 0, its conjugate must be a 0 as well. 1 minus I is also a 0. That's good. Okay, and so therefore, Z minus 1 plus I and Z plus, and Z minus 1 minus I are both factors of PZ, because the rules of polynomials still work even with complex numbers. So that must mean that my quadratic factor must be those two things multiplied together. So I should say this up here, A, because we're now doing part A, aren't we? So let's multiply them together. Z minus 1 plus I, Z minus 1 minus I would be equal to, so Z squared minus 1 minus I Z minus 1 plus I Z plus 1 plus I 1 minus I. So that would be Z squared. Now let's see, minus 1 minus I minus 1 plus I. So that'll be minus 1, well, let's just do it, minus 1 plus I minus 1 minus I of Z plus 1 times 1 is 1, 1 times minus I is minus I times 1 is I times minus I would be minus I squared. So that would be Z squared minus 2Z, because the I and the minus I cancel. So the I and the minus I cancel and that one over as well, and I get 1 minus I squared, which is 1 minus minus 1, which is 2. Okay, so this is a real quadratic factor of PZ. And that's part A done. Let me start a new page and do part B. So what did part B ask me? Find the value of A. Well, I know that P of 1 plus I is 0 because it's a 0 of P. So P of 1 plus I is 0 because that's what it means for 1 plus I to be a 0 of P. So that means that when I sub 1 plus I into the formula, I should get 0. So 1 plus I to the 4 minus 1 plus I cubed plus 1 plus I squared plus 2a should be 0. Okay, so right, well let's do the 1 plus I squared. So that would be 1 squared plus 2I plus I squared plus 2a is 0. And the 1 plus I cubed would be 1 plus I times 1 plus I squared, which would be 1 plus I times 1 plus I squared. And the 1 plus I to the 4 would be 1 plus I squared squared. Alright. So let's see. 2a. So we get 1 plus 2I plus I squared. But I squared is minus 1. So we get 1 plus 2I minus 1, which is just 2I. Okay. And so the 1 plus I squared is 2I. So we get minus 1 plus I times 2I. And we get 2I squared. That's good. That's going to be much easier to do. So 2I squared would be 4 times I squared, which is minus 4. Minus, let's see, 2I plus 2I squared, which would be minus 2. Plus 2I plus 2a is 0. So let's see, we have minus 4 minus 2I plus 2 plus 2I is equal, whoops, not is equal to, plus 2a is 0. The 2i's cancel. Minus 2 plus 2a is 0 because minus 4 plus 2, yep. 2a is 2. A is equal to 1. Excellent. So just to round that off, P of z is equal to z to the 4 minus z cubed plus z squared plus 2a, so plus 2. So one more new page and I'll do part C. C. Express pz as a product of two real quadratic factors and hence find all the other zeros of pz. Well, I could use polynomial long division, I suppose, because I've got just real polynomials, and I can even do that with complex numbers, even though it's harder. But there is another method, and you know how to do polynomial long division, so you could try that one if you wanted, but I'm going to try this method instead. So z to the power of 4 minus z cubed plus z squared plus 2, and let's let it be equal to z squared minus 2z plus 2, which we've already got, times z squared plus bz plus c. Now, by rights, it probably should be az squared plus bz plus c, but I know that the biggest power is 4. I've got a z to the 4 there, and the only way to get 1z to the 4, if I've already got 1z squared, is to multiply it by a 1z squared. So I can shortcut my time there. That's good. So the coefficients of all the powers of z on the left-hand side should match the coefficients of all the powers of z on the right-hand side. And I don't actually have to multiply it out in complete full in order to match the coefficients up, because I can look at the constant terms, for example. So constant term, so if I observe the constant terms, I get 2 on the left-hand side is equal to, now let's just have a look at this. The only way to get a constant term on this side would be to choose the 2 from the first bracket and the c from the second bracket, because otherwise I'd end up with a z in it and that wouldn't be a constant term anymore, so that would be 2c. And so c is 1, so that's good. And then I can compare the z terms. So coefficients of z. So on this side, on the left hand side, there's no z, just z on its own. So the coefficient of z is 0. And on this side, how would I get a z? So I could choose the minus 2z from the first bracket. The only thing I could multiply that by in the second bracket is the c, because otherwise I'd get a z squared or a z cubed or a z cubed. So that would be minus 2cz. On the other hand, I could choose the 2 from the first bracket, and the only thing I could multiply that by in the second bracket to produce a z would be the b. So plus 2bz. Oops, sorry, I don't need the z's, do I? So that's good. Now c is really 1. So let's see, 2c is equal to 2b. So c is equal to b, but c is really 1, so b is 1. Okay, so therefore pz is equal to z squared minus 2z plus 2 times z squared plus z plus 1. Now I already know the zeros that come from the first factor, because they were 1 plus I and 1 minus I. So I just need to factorise the second part to find the zeros of that. Let me make a new page. So what I actually want to do is solve this. Z squared plus Z plus 1 is 0. And I'd have to use a quadratic formula, I think, because I can't see a way of factorising that. So Z would be, let's see, minus b, so minus 1, plus or minus b squared, minus 4 times a times c over 2a. So that would be minus 1 plus or minus 1 minus 4 over 2, which would be minus 1 plus or minus root minus 3 over 2, which would be minus 1 a half plus or minus root 3 over 2i. Because when I square root the minus 1 with that minus 3 there, I'll get an I. So that tells me that my zeros are, the zeros of pz are 1 plus I, 1 minus I, minus a half plus root 3 on 2i, and minus a half minus root 3 on 2i. And it has 4 zeros, as I would expect for a quartic polynomial.